Okay, good morning. Welcome to
MinuteMath number 17.
MinuteMath number 17. This is actually a really neat problem that the Mathematical Association of America is putting out, I guess they are pointing them out too, every day on their website. And this one is a wooden cube, and we're going to pretend this is a wooden cube. N units on a side is painted red on all 6 faces, and then cut into n cubed unit cubes. Exactly 1/4 of the total number of faces of the unit cubes are red. What is n? Okay, so before we dive into solving this problem, let's talk about with a 3x3 cube. First of all, how many unit cubes are there if I cut this, if I broke this apart? It has 3, this is a 3x3x3 cube. So how many little unit cubes? There would be 27 unit cubes, okay? Now, the tricky thing here to figure out is how many faces of this, if I chopped it up into unit cubes, would be painted or have stickers on them. Okay? How could we figure that out?
We can figure out the corners, the middle edge pieces, and the middle pieces.
Okay, we could do that. Yep. Do you see any other way we could figure out how many stickers there are on this cube?
Well, we could figure out how many there are in one face.
Yeah.
Then multiply that by 6.
Yeah, we could do that. Which way is easier?
The second way.
The second way. So how many stickers are there on a face?
It's 9.
9, and then 9 times 6 is?
9 times 6 is 54.
54, okay, very good. So with this one, if this was our example, it was a 3x3 cube, we would have 54 faces that were painted red, or in our example have stickers on them.
Yep.
And how many total faces would we have? We would have 27 cubes. And how many cubes does each face have?
Each of the faces.
Each of the small cubes, when we take them out, how many faces does a cube have?
6.
So we would have 27 times 6. Now 54 is 9 times 6 over 27 times 6. And what does this equal?
We can cancel a 6 and factor in 9 from the 27.
Okay, so what does this equal for our example cube?
It's 1/3.
1/3. Okay, so this one has 1/3. Okay. So let's see if we can do it not with a specific one, but in general. Okay. So we have an n by n cube.
N by n by n.
N by n by n cube. So how many little cubes do we end up having?
We have...
Instead of 3x3x3, we have n by n by n. So how many little cubes do we have?
It's n cubed.
N cubed. And how many faces does each cube have?
Each cube is 6 faces.
Okay, so we have 6 n cubed little faces. Now we have to figure out how many faces would have stickers on them. If instead this was 3x3x3, instead it's n by n by n. Sorry. So how many faces, how many stickers does each face have?
Well, on this one it's 9.
And on this one it's 9. But if this was n by n by n, if it's 3x3x3, we have 9 on each face. If it's n by n by n, how many are on each face?
N squared.
N squared, because it's a square, and n by n squared. And how many faces are there?
So n squared, there's n squared and there's 6 faces.
6 faces, very good. So we have 6 times n cubed over 6 times n squared. We can cancel the 6's and get n squared over n cubed, which simplifies to be what?
You can factor in n squared,
Okay.
which simplifies to be 1 over n.
1 over n, very good. 1 over n, and that equals 1/4. So what does n equal?
N is 1. Well, it says 1/4 of the total number.
Right. So we figured out, here's the fraction of sides that have stickers to total sides, and we got that fraction was 1 over n. And we have 1 over n equals 1/4. So what does n equal?
N is 4.
N equals?
4. 4. 4. 4.
4. Yep. So n equals 4. That's a pretty cool problem, right?
Yeah.
Pretty cool. All right, good job. High five. Who ever thought we'd be able to use a Rubik's Cube in one of these problems?